Awesome. All good? Okay, so welcome everyone once again to our fourth OSA AI Club meeting, presented by the Professional Networking Committee of the, Odisha Society of the Americas. Thank you all for joining, and for those who couldn't join, thank you for, tuning into the recording and watching. We really appreciate it, and we hope you learned something new from today. So with that, I would like to start off by introducing our three speakers today. The first one being Professor Abani Patra, who is a professor of math and computer science and center director at Tufts Institute for AI. Professor researches computational issues in large scale and data-driven modeling. He is trained in computational mathematics and was the founding director for the Institute for Computational and Data Sciences at the University of Buffalo, and has directed programs at the National Science Foundation and U.S. Department of Energy. Our second author for today will be Debu Panda, who is the head of product at Amazon Web Services, AWS. He is recognized as an industry leader in analytics, application platforms, and database technologies. Mr. Panda has published numerous articles on analytics, enterprise Java, and databases, and has presented at multiple conferences. Beyond technology, he is also a poet and a writer, a rare combination of technical depth and creative spirit. He is the co-author of the book AI for Kids in the Odia language, so please give a warm welcome to him as well. And our third speaker today is Mr. Anjan Panda, who is the co-founder of Odisha AI, a nonprofit organization to bring awareness about AI in Odia, and also the co-founder and CEO of Dublin AI. He is a longtime volunteer here with OSA and various different OSA activities and has been a key partner to the success of this endeavor. He is also going to lead us through the hands-on section today. So with that, let's dive into our speakers.
Thank you for the invitation. Didn't get a lot of time to think about it, but last night I was thinking about it and I saw the titles of the other two and I said, I'm the boring guy here. I'm not going to do that. I will change it a little bit. Can I share some slides?
Yes, please.
Let me see if I can. Can you see my screen?
Yes.
Okay. So the idea that I want you to think through with a particular example from my professional interest, and which I think these days is quite interesting for Odisha also. I'm sorry. Yeah. Okay. Can you all hear me?
Yes,
Hello.
you can continue. Right.
So I'm talking about. So I'm going to talk about how we go through this whole process of data to AI modeling to decisions to what happens after that. But I will do it in the context of a specific example from disaster management. That should give you a little bit more thought. Many of you are from California, so the topic I think you'll find quite interesting. Uh, Number one, AI is changing how we decide. Okay, it has changed in many cases. I was just reading about this experiment where there is a store that's completely AI run now today morning. So the decision-making process, which we've done computer modeling to get information for many, many, many years now, but the decision-making was something that was left to human. But everything from war, Palantir's Maven, whatever, decision making is increasingly being delegated or given over to the AI with the rhetoric that there is still a human somewhere in charge. That is to be seen. But we have to start preparing for the idea that AI will make decisions. The question is what decisions are appropriate, what decisions are not appropriate, and how does one maintain this carefully? So let me give you some thoughts here. I will start with this example, that problem that I've been working on for, I don't know, many years now, more than 15. This is just south of LA. You have wildfire, very popular this time of year, especially. Then there is rain in December. And then there's debris flows, which do all kinds of bad things. So your TV headlines will tell you enough about it, so I won't go there. And for many years, we've been doing this very complicated, expensive calculations to inform people. I don't even want you to read what's inside the blue box there, but that's the kind of very complicated mathematical processes that have been used, expensive, never timely. So it was great to do hindcasts, but forecast was almost always impossible. I could tell you 3 weeks after the wildfire and after the flow, this is why there was a landslide here. Well, you're already dead. How does it matter? The ideas can be moved from that to forecast, and AI promises to allow us to do that. Of course, there is not time to do this in a real time fashion. So the decision making will have to be relegated to the AI. How does one do that? If AI tells you to run for your life, should you? Or should you say, wait a minute, you got the wrong county address, my friend? This is the Springfield, Missouri. This is not Springfield, California. Okay, so that stupidities can happen with AI very carefully. So what we have been doing so far is we have taken this rich history of calculations we have done over the years and using that to create to train AI. Okay, to train AI based surrogates of all this millions of hours of supercomputer time down to a foundation model, which can then be tuned and so on. And this is some of your AI specialists will get some kick out of the architecture here. Not particularly complicated, but there are some nuances that may enjoy making it work in this context. There's a dynamic modeling here, which is not common in a lot of practiced AI now. There's also a lot of uncertainty in data, in principles, in people, in data itself that comes from disparate sources. How do you all bring that together? So we do look at many scenarios. We try to do some assignment of probabilities, which is again a little bit heuristic, but it's better than not having anything that you essentially allow people to have some judgment of this is more likely, this is more less likely, with some degree of caution that this is not an absolute number. If it says, you all look at the rainfall forecast, it says 90% chance of rain. Is it really 90%? 90% of what? But if it says 90% as opposed to 30%, you know that you're not going to carry an umbrella when it's 30%, but you will carry an umbrella when it's 90%. So that relative degree of certainty, that is something I think we have learned how to use well in our personal decision making. With some fuzziness, I might say, well, it's 30%. I'll just put on a light rain jacket. I won't carry a heavy umbrella. So this kind of information, this is helping us decide. Now, question is, can you actually automate these ideas? Because you'll have to do things in time. So that's kind of the overall process. You have some observations, you have some modeling, data processing, analysis, AI, and then you move to prediction. Every one of these stages that I have here, there's going to be error, there's going to be uncertainty, there's going to be outcomes that are, what's the polite word people use now? Hallucinations. Okay. Yeah, of course, our surrogate works perfectly, otherwise I wouldn't talk about it. Correlations between the very complicated physical processes and the models that took millions of supercomputing and the AI models, very good. But that's not the point. If I only can reproduce what happened in the past, not very useful. All the training data I have is from the past. That's not very useful. As in, it's not guaranteed that the future will be the same as the past. Right? So how do you extrapolate to new places, to new times, to new sites? I have trained on Southern LA. I'm Southern California, Northern LA. How do I use that to predict something in Arizona? How do I use that to predict something in the Bay Area? Okay, so how do I go from one to the other? Those are tough open questions. Do you have enough data? Are you able to account for error and uncertainty? How does that model transfer? What's the condition for that model to transfer? These are not closed questions. In some domains, there is enough data. I'm talking about consumer buying preference at Target or whatever. We have billions of transactions to train on. I have 20 wildfire that data sets if I'm lucky. I have three mountains and I want to predict on the fourth. So how does one deal with it in this sort of limited information, limited data, and of course then putting it all together? So I'll stay away from the computing aspect because the audience I suspect is a little bit away from the hardcore computing business, but these ideas are general. So how do you extrapolate these data-driven models to new sites? Traditionally, when I did those calculations, I showed you that blue box, which I didn't go into. Those were based on very sensible physical principles. Newton's law of motion, force equals mass times acceleration. That is universal. That extrapolates everywhere. What is the equivalent when we just do a training on 50 data sets? And I discovered the extrapolatory essence of it that translates to a new place. That is the challenge that we are not yet ready yet. Think. How do you get the universal principles? Do we have adequate data? Let me bring up another thought here. So let's say I have trained this model on Southern California. I have enough observations, and I want to predict what's going to happen if something goes wrong in Northern California or Arizona, for that matter. This is a problem that we had. This is Oakwood in East California, somewhere around the border with Arizona. Okay, we have trained on everything on this Southern California site. So how do we go there? So this is the abstraction that I like to think about. You have built a model with some training data, some training algorithm. You use convolution network, you've used transformer, you've used this, you've got data from soil moisture data, you got remote sensing data on forestry, you got data on people, roads, this, that, you got 100 different types of data. You put it together and now you have a model. Okay. Question that comes to you is I'm watching a new fire build up and a new rainstorm predicted in Northern California. How do I make that prediction? So I have a prediction scenario and a model. Okay. Now this is something that modelers like us should always do, but rarely do. We give you our model, ChatGPT, whatever. We don't tell you what was it trained on. We don't tell you what it does not know. We only tell you because this is how we sell, that this is what it can do. Look, it got 99% accuracy. It got so much recall. It got so much precision. Look at my area under curve. Okay. But what we don't tell you is how is it going to be useful in the prediction context you have? I have my 80-20 test split. I am fantastic. I got 99% accuracy. Very good. But if it's all in LA, how do we know it's going to work in San Francisco? How do we know it's going to work in Arizona? We don't. Because the model did not come with a confession of what it knows. And the model, and this is where there is a lot of computer science research needed, how does a human being, I mean, I go to a cardiologist and I ask him, sir, can you look at my knee? He's going to laugh at me. I'm a heart doctor. What do you think? Why are you wasting my time? Right? So this model that I've trained so beautifully on Southern California, it should know enough to tell me when I show up with an Arizona data set, go away, I don't know anything about Arizona. The rainfall is it's only 20 millimeter a year. I am dealing with 200 millimeter a year average rainfall. So your model is soil moisture, everything is completely different. So models are not self-aware, or there is no percentage in telling somebody that you can't use this. There's a percentage in telling somebody that you can use it, because every one of these models is built to sell. I don't care if it's academic. The academic guy is also trying to get more citations. The commercial guy, of course, is trying to get money. So that notion of model being aware of its own limitations, that is culture that is not currently practiced. It may have to be mandated. It may have to be regulated. When you buy a box of cereal, there is a label on the back that says it has 20 grams of sugar. So if you're a diabetic, please don't eat it. Our model should come with a nutrition card. What can the model not do? Not just what can the model do, because everybody's proud of what their model can do. But moving forward, if you're going to delegate critical decision making, model must advertise its limitations. Anyway, so getting back to this, I have this very simple principle. If the distance hour measured between your scenario of prediction and your training data is smaller than some don't, then your prediction is likely valid. So this is the beginning of a lot of good computer science, I think. And we started doing some of it, but very, very open for new thoughts on how to actually think about not what a model can do, but how do we compactly and precisely communicate what a model cannot do? How do we test for what a model cannot do? We test for what a model can do. We don't test for what a model cannot do. And that, to me, if you're going to delegate, there's a human in the loop, it's fine. The human will not take their child to a cardiologist when they have a knee problem. They have context, they know. But if there's one agent with limited knowledge, limited context that's making this decision, it does not know. It will take your niece problem to a cardiologist. And if the cardiologist would confess and say, I can't do it, that would still be okay. But the AI cardiologist would probably prescribe heart medicine for the knee pain because it doesn't know any better. It is defined by its training, by its context, which it thinks is complete. Every AI model thinks that it knows everything. That's the bloody problem. Anyway, so we came up in this case with some very careful criteria because the dominant thing is the topography. So we started looking at, okay, if one mountain looks like this, another mountain looks like that, can we actually come up with a quantitative measure of the distance between these mountains? And then we can calibrate if this transfer learning problem is well posed or not. It turns out that you can do this with some fantastic degree of accuracy in this case, because every mountain you can reduce it to a data reduction, dimension reduction you can do. You can reduce it to a small signature of these histograms. Then I can find a distance between the histograms. It's like I look at your face and you look at your signature, and I can individualize each topography has such a signature, and I can tell you when this will work or not. So it's a very, very limited, very, very finite problem I can solve. But how do we solve it in a more general context? That is open research, I think. So do this. I'm not going to go there. But now a little bit more, now that you have a particular concrete example in mind, I start thinking more generally. How do we do this automation of modeling and decision? If you look at the first gray bullet, that is how things have worked so far. Data gives you some models, either data-driven models, but then there is a process understanding. F equals ma is derived from that model. Newton plotted apple fell, bigger apple fell, whatever, and then he got a curve out of that and he extracted information. And then that was extrapolated. That was used for predictions. And human decisions were made on those well-founded predictions. Okay. There was impact and there's more data and so on. So that's the old model, that's bullet one. That was practiced for, like I like to say, from Aristotle to space shuttle. Okay. So we've come a long way with that model. The human understanding augmented by computation, by observation, by thinking, very, very successful. Okay, you all fly. The newest airplanes were still built this way. You all saw the Artemis, the basic Artemis design was probably mostly built that way. Okay, so this is a very successful paradigm and will be practiced for many more years. The next thing that has now happened is that these data-driven models have become powerful enough. Think about your classic recommender systems. It tells me, based on my past purchasing history, Mr. Patra, you like red shirts. So here's the red plus slightly blue shirt. You should buy this next. It'll show up in my Amazon box as soon as I log in. New shirt for user. So there's personalization because of the power of the data. Because one of the things that was wrong about this first paradigm, it's a general prescription. It's a general prescription that's assumed to hold universally. When you're talking about physics, that's fine. We start talking about people, we start talking about human things that affect humans. Humans are very problematic. Every one of them is different. Even though we have 8 billion of them, you'd think two of them would be equal. Even freaking twins are not equivalent. Okay, there's a whole field of medicine called twin studies. What's the difference between twins? But getting back to this, but this is now something we are getting better at. This is something that AI is able to do. It's able to combine our knowledge, our intuition, wherever captured and represented properly, into some personalized predictions. But note the key thing, the human is still making the decision. Okay. I think this is actually pretty good because the weakness of the previous paradigm was it was one prescription for the entire planet. Doesn't work. Okay. If you go to a doctor now with a serious disease, they'll look at, oh, the statistics say that your cancer or whatever is such. Because your artery has narrowed this much, your chance of heart attack is this much. But that is statistical prediction for an entire population. Okay. Depends on how you train. I was talking to a doctor yesterday. They had these models for this thing, cardiological risk and so on, ICU recovery and cardio, this thing. It was almost exclusively trained on Caucasian white populations in the Northeast. So Asians, our failure rate in that model was 30–40%. If you're making ICU decisions, that's unacceptable. But overall, that model did just fine. It had 90+% prediction. Those are the challenges that are currently people are working on, and I think we'll get those. But here's the one that I'm scared about, the last one. These models will start becoming completely smart. They will have agentic independence, and they'll make personalized decisions for us. Are we ready for that? How does this agent know that this model that's being used in the AI, in the ICU, was trained only on Caucasian males? A good doctor now knows that. So if they see an Asian patient, they will take that model prediction, but they will take that into consideration that, okay, the model prediction says X, but this is an Asian patient, and we know that the models are not the best for this because it wasn't trained on that. So that distance between prediction scenario and training data is high. They know that. So they will treat that model's result with some caution because AI won't tell them that. The model will not tell them that. Model says this guy's got blah, blah, blah. Anyway, so I think I've almost used up my time, but let's see. So, and to bring up a few questions, automation and AI. One of the ways we have had safe decision making, if you look at any company process, any process where you make critical decisions, a good safety process or safety culture is built by many eyes. There's a committee. Why is there a committee? Because one person's weakness, one person's biases, one person's abilities should not define the decision if it's critical. We make it go through a committee, whether you're in OSA or you're in nuclear regulation. Okay. So that's what's the many eyes of automated decision making with an agent? No eyes. So let's think about that for a second. We will go where traditionally we know that many eyes is what promotes safety. We are now willing to live with a culture that's no eyes. We have to figure out how to put many eyes back into any automated decision process. Is it competing agents? I don't know. Maybe that's a technology solution. But maybe there's a way that the agents are sufficiently aware that they ask for the many eyes when the decision is critical enough. If it's trying to decide whether what my hair length should be, given that I have none, and the automated razor cuts me, that's fine. Makes a mistake, it makes a mistake. I'll just look a little funny for 2 weeks. But if it's going to decide on my medicine dose, I want many doctors to think about it. The data comes from many. That's the other thing. So when there is a mistake, I told you that the ICU doctor can make a decision because they know what was training. There is a provenance of the training data that he's aware of. Where did the data that came to train this doctor, train this model? But if you have this multi-source, multi-thing automated training, this is going out and getting local resource RAG or whatever, provenance is not clear anymore. Even if I know that this model is not reliable, what part of the model is not reliable? Who do I blame? Where do I get new data to fix that problem? That's rarely done. Is there some methodology for that? Yeah, there is some methodology. You can do some sensitivity type calculations and advertise that. But modeling culture does not reward that, right? Okay, modeling culture does not reward that right now. So if somebody comes to you with an AI model, you can always ask the question, okay, so when it goes wrong, can you tell me why it went wrong? Ask a modeler that question. If they can't answer that question, then degrade that model. Find the one that can actually answer that question. Because there is extra work involved in doing that. You have to construct auxiliary models. You have to use shape factors or whatever, explanatory models. People don't always do that. Anyway, so automated discovery. So and so on. So you have to understand two things here: autonomy and agency. Who has agency on the decision making when you do when you do automation? If you create something that's autonomous, who still has agency? Where does the boundary between the machine and the human last? Where is it established? Are you comfortable with that line? What decisions are correctly delegated? What decisions are not correctly delegated? And then to summarize, basically, does the AI know when it does not know? Does the human know when to trust the AI? Those are the questions that we should ask every time there's a new modeling application. So I will now shut up and hopefully we'll have some conversation.
Yeah, thank you, Abani. Anjan, did you collect any questions?
There is one question that has come, but so I was I'm especially curious on someone here called Ratanlal Mahanta. Anyway, he was a judge of hackathon that
Mhm.
was conducted part of the symposium which you are organizing. So Ratan, I am working with Ratan to build quant shops in different parts of Odisha.
Mm.
So basically, mathematics guys. And so that's what I'm working on, and I was expecting him to ask a question, but so
Nerd club. You're building nerd club.
exactly. So the latter part, right? So two questions I would have. One is, how do we introduce this complex concepts to the kids, right? I'm trying to establish a correlation between your
Mm.
session and the next session.
Yes, sir. I will not go down to kids. I'll leave that to the way. But I will talk about high school students. I work with some high school students because of mostly social reasons, but I've started enjoying it a lot. Why? Because they don't know that they don't know. Okay, so if you speak to them, they're receptive to ideas. There's idea that I told you that okay, you just built your model. I asked them the first question. So what is your model not know? What does your model? Where will they? What would you not use the model for? First time I asked that question, they kind of look at me funny. You asked me to model this, and find this. You gave me 5 images, and you're asking me to run this CNN model. They've all learned how to do machine learning, by the way. I don't know where the parents help them. I don't know, but they all know how to play with Python and things like that. Okay, these are mostly juniors and seniors, so they know how to quickly access a model. Google Colab, this that. But when I asked them the question, okay, Pete, how does this model? What do you not predict with this model? First time they hear that, they kind of, didn't think of that. But then they start doing the following. They tell them, okay, so let's just like what is the Lakshman Rekha? What boundary should not be crossed? You ask them that question. They get that idea much faster than my PhD students sometimes. Because my PhD student is very proud of his method. He's married to his method, I may say. And for them to accept or look for limitations is psychologically much harder. So I find working with the kids pretty easy as long as you're willing to translate it into concepts that are not that hard to do, none of this requires AP Calculus 5 score or anything like that. A lot of these ideas are basic. Okay, you fit a least square line, which you learned in fifth grade. Everything that I said about a model can be explained in terms of y equals mx plus b fitted to 50 points of data. Okay, so the idea of thinking about models fundamentally, not modeling technology or modeling process, that has to happen. Because what happens now in most of the education, high school, middle school, college, everybody is focused on the technology and somehow showing off how great the model is. We need to understand the limitations of knowledge much more, limitations of technology much, much more. When we introduce a technology, the culture has to be to simultaneously talk about appropriateness of the technology. When is it to be used? Okay, carry a toolbox. You have a hammer, you have a screwdriver, you have a Phillips screwdriver, you have a file. So which tool is useful for what? These are simple ideas. They need to be taught with discipline. Okay. It's not rocket science, as they say, and I've actually done rocket science for 5, 10 years of my life. So I have another project I didn't talk about. We actually were working on modeling these solid rockets. But the point is that it's not complicated. These ideas are universal, they're simple. So whether it's kids or adults or practicing professionals with 30 years experience, it's just culture, discipline and culture in your thinking. Okay. That's what I realized, that it's not idea that this has to require some PhD. No, 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 not at all. In fact, the problem is we have graduated too damn many PhDs who don't think. Hopefully that answers your question a little bit.
It does. It does. It does. In fact, it triggered a more complex thing. After which, I will. May I ask that question, Devu bhai? I'll need your permission as well. I'm probably eating this. So this is something that I do face as a part of community building, right? So and this is becoming more and more into the discourses of alignment, AI alignment, basically trust, right?
Mhm.
So technologists tried with trustless architecture that got into crypto hype, and that's a mess there. Security systems are playing mouse and cat game with bad guy versus good guy. So trust is a very complex cognitive, emotional, social construct. Now with this, the AI everywhere, how do we even model the trust in a new times, right? What are the ways to think about it? So I'm sorry, I'm jumping from
No, 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 no.
one plane to another
You
plane.
asked the right question. I will start from the example I gave. Your cereal box comes with a nutrition label, which tells you it has sugar, it has this, it has salt, it has the color, it has this, it has that. So I can trust that label. Then I can trust that cereal. Then I can say that, okay, I have a bowl of cereal 2 days a week because I can only take so much sugar. Okay. So the question that you're asking, how do we promote trust? Trust comes with transparency and communication. A model, no matter how sophisticated or how simple, must have a nutrition label. It must have careful description of what it can do, careful description of what went into its training, so you know what it cannot do also, directly or implicitly. Okay. So we don't ask a model the questions it is not supposed to answer. If I have a model for San Francisco rainfall that is good for 24 hours, we should not ask it to predict in 48 hours or 96 hours because it will be dangerous. You cannot make a good decision based on that. I look at this model that's good for 24 hours and I don't order tents for my guests. They come in and my party is washed out. So there are immediate consequences. I lose all trust in that model. Why did I lose trust? I lost trust because I asked the model an inappropriate question. And I asked the model an inappropriate question because it did not tell me that it doesn't know. So, this idea of understanding suitability, appropriateness of a technology, that is the problem. Commercialization can sometimes hate that. What are the side effects are in fine print? Every drug advertisement, the side effects are in fine print. So, that's the problem. So trust has to come with disclosure. Trust has to come with transparency, whether it's mandated or whether it is cultural and we do it by habit. That's the problem. I think right now we are all so motivated with individual progress. It has to be mandated. Mandates are never going to be 100% effective because we're very smart people. We'll find some way of cheating. Even what Mahabharata has that, right? Yudhishthira lowered his voice when he said, Ashwathama Hata Hasti. He put the Hasti in fine print, which badly. So he did not disclose properly, for which he was punished, I'm sure. But that is not new. This idea that we hide our limitations is not new. But how does one trust? If you want trust, you want communication, you want disclosure. That's simple. Anyway, Utkal Babu had a small question in the chat.
Yeah,
We understand the model developers have lots of ways of finding when it went wrong and fix it. How, as the users who are the inference and can find out whether the output is correct or not? This is essential part to trusting AI. Couldn't agree with you more, sir. The end users are often not sophisticated enough to discover the limitations of a model. But here's what you can do, and one tries to do, but it's not always easy to do. If you have a certain use in mind, I buy a mixie, I buy a gas range, I buy whatever, I buy a car. I should have the ability to test it in the manner I will use it. If I buy a motorbike as transportation and I try to use it where the temperature is minus 20, it might look great in Southern California. Okay, I buy my fancy new Royal Enfield 500cc bike and I bring it to Boston and try to use it in November. That will not be very comfortable. So, what is my projected usage? Is the model able to support that usage? That's a question that every end user should have the right to ask the modeler or be able to independently verify. If you cannot verify, don't buy. If people refuse to buy until they can verify their thing, then industry will be forced to provide that information. Why does every cereal maker provide that nutrition label now? Firstly, it was mandated, but now if they don't, I compare the one from General Mills to the one from Whole Foods, and I buy the one that I trust. Trust is a valuable marketing tool. It can be competitive advantage. So a modeler who promotes trust does that. Look at this Anthropic fellow. He's doing such a masterful job of promoting trust. Okay. I mean, I don't know how much of it is true, how much of it is hype and marketing. I don't know. But look at that guy. He's using trust as his marketing advantage over the other guys. And it's working. Look at his growth curve. He's beating the heck out of everybody else. I don't think their models are bad or anything, but I don't know if they're orders of magnitude better than the other guys either. But right now, if you ask the average software engineer, oh, cloud is God, right? So going back to, so that's the thing. Trust has to be built and so on.
thank you.
I think
I think
Ratan has a question also, but I think I will answer him offline. We are out of time.
Anushka, please take it away.
Thank you so much. Sorry for the background noise. Papa de matcha bhaji for lunch. So there's some voice in the background, but moving on to our next speaker, Mr. Debu Panda, head of product at AWS and also author of AI for Kids. Please take it away, Mr. Panda.
Yeah, sure. Give me 1 minute. All right, guys. Are you able to see my screen?
Yeah.
Are you able to hear me?
Yes.
All right. Hey, guys. Thanks, Dr. Patra, for the inspirational talk and, going into so much details. You know, I, I'm not that deep into AI or data. So my job is to democratize AI. That means basically, folks like you and all, like I work with the tons of PhDs who build their model or build their application, whatever you want to provide. And my job is to make sure that how we make it easier for users to consume, AI. Okay. And so as a part of that, I have launched a lot of features that end users use AI with either a SQL or natural language interface in my products at AWS. Okay. And like about 4 or 5 years back when the Odisha ML started, okay, that's when, Anjan asked me and Prasant Bhai to see whether we should write a book for AI for kids. Okay. And at that time, my son was, I think, 10th or 11th grade. And one day he came and told me that he is the president of the AI club his school. I said, yeah, well, he is already high schooler. He is the president of AI club. and I built some prediction model for predicting crop in Odisha. Okay, and he had contacted some folks in researchers in India to get training data to train his model. So without even me helping there. So then I thought, like, do we really need a book for kids? Kids here in the US are so knowledgeable. They are already building models. They are so good in Python, better than me, and we need it. So me and Prasant Bhai were discussing about this, and around that time, about a year later, I went to India and I saw the knowledge gap between the high school's kids. There, they are very good in math. They study a lot for their entrance examinations, but they are not out of the box. For example, learning about what is happening in the industry. And then I went back to my high school. I studied all my entire life in Odia school. Okay. And I went to my middle English, my ME school as well as my high school, and I see the Odia kids even don't know how to operate computers, kind of thing, you can say. So then me and I spoke to Prasant Bhai that there is a need for writing a book, at least, if not for the kids in the US, we should write a book for the kids in India. Okay. And that's how they started. So Prasant Bhai, Prasant Bera, he is a, child literature writer, and then that's how we started. So we started the English book first, and then it took a lot of time for me to write the Odia version of the book. Uh, fast. I think the English version probably we both together wrote in probably like 6-7 months, and it took me 9 to 10 months to write the Odia version because we didn't want to translate word by word, because there was a lot of context that we used in the book. Like, for example, we had quote for example, Harry Potter, that kids in Odisha, in Odia, they will not know Harry Potter is. So we translated that we changed that change it to, for example, Rebati story or something like that, contextualize for Odisha. Okay. And you know what? Our effort has been, like, for example, we give these books for free. So we have given about 800 copies to different schools and libraries in India. And also many of the OSA community members, help donate these books to their schools or library. I'll discuss that later on. But before that, well, let's talk about, you know, what is AI is. As parents, we are also learning every day. You know, every day to me, as basically every day I try to learn something new about a new technology, writing style, poems, whatever it is. So for me, I learn every day. And when my kids were there, I was, when the kids were small, I used to tell them story. Pretty much every parent in the US read stories to their kids, and I used to tell them original stories, like come up with all uh, random ideas and translate this story. And our book actually starts with telling stories, like about AI, the father telling about AI to the daughter. But anyway, so as many of us are parents in this, so we should learn this together. So what is AI? So going to the basics, basically, I'm just trying to finish it within 15 minutes allocated to me. So, what is AI? AI is basically nothing but, and let me just tell you application of AI first before I go there. So Anjan asked me to do this presentation yesterday evening around like 3 or 4 p.m. And I didn't have any presentation. So, but I had the PDF version of my book. So I fed this to an AI model and asked him, can you create a presentation for 15 minutes presentation? And this presentation is entirely created by AI. If I had done this presentation, probably would have taken me some 10-15 hours. Um, but this presentation is completely created by AI. So what is AI? AI actually helps computer think and learn like humans. So if you think about human brain, um, you know, make a lot of decisions based on previous experience, current context, all kind of thing. So similarly, we as a part of AI, we are training computers, you know, uh, to think like human and make decisions. And you can, see the use of AI every day. Everyone in among us is out there using AI pretty much every day. So if you go to you're using Siri or Alexa or Google Assistant to ask questions, that is driven by AI. If you're driving car, you're using Map or Apple Map or Google Map, it is using AI to give you recommendation. You're going to Amazon, as Dr. Patra was telling, that it gives personalized recommendation, book, or merchandise recommendation. So everything is driven by AI. You know, is so AI is everywhere. You are using at home, you are using at school. If you are playing games, you know, doctors are making recommendations. There is self-driving cars. You know, uh, you can make crop prediction. It is being used by government agency or misused by government agency. You can say so AI is used everywhere. So what is an AI model? So AI model, you can say, is AI's brain. Okay. And you, like, for example, as a kid, you when you try to learn riding a bike, you fall down a lot fast. Okay. Then you practice every day. You get better and better. And finally you become ride like a pro. So your brain is a kind of a model that stores everything if you learn and apply that to make the decisions. Similarly, a AI model is AI's brain, you can say. And the data examples they provide, to train the model, like for example, you keep pictures or all the published data, all the different newspaper or books or whatsoever you are providing based on the what kind of decisions that model is making. And that data is being used to make future decisions. So think about, there are different ingredients of AI, and then let's say you're learning dancing. Okay, the training data that you are providing, like your teacher gives you dance techniques, how do you want to train? you know and then the algorithms that drives it, there is algorithm that is being built for your model that to make the decisions. So think about, your dance teacher tells, okay, do this way or that way, don't do this way. So that's a dance choreography, for example. Similarly, you need a powerful computer to make your a model to run and they make decisions. So think about that, dance practice as an example. How AI learns. So we kind of give a lot of examples or training data, feed thousands or let's say, think about, there is a cat model. And the sole job of the cat model is to identify whether the picture of a cat or no. It tells only thing is that the cat model recognizes whether it's a picture of a cat or not. So in order to train the model, first we have to give thousands of pictures with the labels. Means basically, so think about, okay, this is all cat model. They are different kind of cats, and then it kind of learns from those data. Okay, and more data that you provide, it gets smarter. Okay. So give an example, like for example, so you are giving a lot of, cat, fitting a lot of cat model, cat pictures to the model. Okay. And then the model kind of makes the decisions based on the previous data and understanding the pattern. So then let's say, for example, your model is trained, then you provide a completely new picture, which the model has not seen before. Okay. and the model determines whether that's a cat or a not. So it's again, like for example, so it's similar to you. For example, when you are growing up, your parents are teaching you this is a cat, this is a dog, and this is a cat. And like for example, I'll give an example of my like daughter when she was young. Like the first thing we're trying to teach her everything in Odia. So, we used to live in Seattle. So there are lots of crows that used to come to our backyard. So used to tell her that is kua, that is kua, that is kua. That's the first, like, besides mom and dad, Bapa and Ma, first things he learned is that is kua. Okay. Then every animal she sees, that's a kua. Then it keeps, no, this is not kua. This is chotia. This is kukura. So it's like, then she learned when, and say, okay, this is kukura, this is kua. So it's similar things, basically. So you tell the model, it's like a human brain is from whatever the training data that you provide, based on that, it is going to make a decision. When you see a new, like you see a new kind of new breed of dog, for example, when you are young, you may not know, but that you might not have seen that breed of dog, but your brain tells, no, this is a dog, this is not a cat. Similarly, a trend model, looking at the pattern, decides it's a cat or not. So think about, as a kid, training is studying every day, learning from examples with answers, and inference or prediction is your test day, because you might get a completely new questions, okay, and which you might not have seen, but from your experience, or all the hard work that you have done, you you learn that, and you're writing, giving the right answer. So that's your inference, you could say. Why AI is amazing? So the first example that I gave you, for example, this presentation was built by me within 5 minutes. If like it was, some other day, if I had not used AI, then probably I would have taken 10 to 12 hours to build such an amazing presentation with like which with like a color appropriate to kids and others, for example, which even I have might not have good understanding of what colors the kids will like. So I just gave some few prompts to tell, okay, to generate this. So it saves time. It does boring job, a repetitive thing. Like for example, somebody looking at customer ticket, okay, that my order didn't arrive today. So right now a customer service person goes and looks at it and then does the research. Think about, that's a very boring job, or scheduling people's calendar. Many of the things, you know can be eliminated or can be automated without saves a lot of time, without doing a lot of work. Like for example, I was giving an example, a real example of one of my customer. So like one of a pharmaceutical company said they do some analysis, they look at different kind of data. So the business analyst used to take 8 to 9 hours looking at different past data to make a decision whether this prescription will work for this patient or not. Which was like every analyst used to take 8 or 9 hours to for one case. Now they do in 0.5 second using AI. So and what they told is basically now the business analyst can do a lot more work than and better work than just doing this this data and then manually collating the data from different spreadsheet to make this decision. And now it helps people. You see, not only uh, you know drug discovery, you know you can use it for, let's say, uh, improving education system. So it makes life better for many people. Like for example, for us, right now, for example, if we used to like I used to have a problem with United. Now, for example, I used to call them, I would wait for 50 minutes before a customer service person can attend to my call. Now I go to their chat, I ask these questions, and then they resolve it. So it makes life easier for many of us. And similarly, like when people are visiting new country, for example, you do not understand the language, you can ask the translator instead of learning this language in real time. It solves a lot of hard problem. For example, uh, giving personalized product recommendation. That is, if you have millions of users in your system, it is very, very difficult to do that. Now, AI can do it. And AI never takes any vacation. So it can work all the time. All right. So whatever it is, AI is not perfect. AI can make mistakes, especially in very new situations. And then sometimes AI can't explain why it decided. Humans still need to, like, there was a big discussion about trusting an AI model. You think about, you know, when there is a new intern there in your system. So I treat AI right now as my intern. Okay. I do not believe it completely. So when a new intern comes, it requires a lot of supervision until they learn well for whatever we are asking him to do, or a new employee. So it's exactly like that. I treat, like, whenever I'm using my new intern who does a lot of things for me very quickly, or but they may falter, and then I have to keep on giving guidance to make things better. It's similar to that. And there was a trust, or like, how do I you know depend on AI? So think about, like, 20 years back, when the packaged applications like PeopleSoft or Oracle or SAP came in. Prior to that, every customer was building their own HR system or manufacturing system, or so but these systems can't quite become very popular because it's kind of eliminated the need for building custom applications for each of the organization. And a company like Oracle, where I work, for example, they build financial application, and this financial application of general ledger, or creating your balance sheet or trial balance, is similar to every organization in the world. So they followed and then built a common application. But not every company just trusts their application. They tested it, customized to their need. Okay, it's similar to that. When you are using AI as an organization, you cannot just trust it because it might make mistakes. It might not be suitable for your organization. So many of the organization are AI police now, for example. The third final thing is that AI doesn't have feelings like humans do. Okay. So the important rule is to provide, test right amount of data, test it. Like, if you do not provide cat good, bad cat, you do not provide the right cat data to the cat model. And, like, for example, some of them are blood cat, or you give a tree or a dog and tell this is a cat. The model is going to make mistake. So you have to make sure that if you are building your own custom model, you need to provide cat data. Next, come to this. This is like, what is generative AI? So this is like, after Chat GPT, this become quite popular everywhere. You know, Generative AI is an AI that can create brand new things. Like, for example, you can ask them to write stories or text. Like, for example, one of my friend asked ChatGPT to write a poem on me, and because there is a lot of public information on me, and he sent a Odia poem on me just using ChatGPT. You know, so you can create new images. Like, I created a PowerPoint. You can, like, now people are creating music and video using generative AI. So how it works? It learns of millions or billions of examples available, finds patterns and style, and then creates something new. So as the cat model was, like for example, earlier was able to just determine whether it is a cat or not. Now you can actually generate cat. Like for example, I have a cat. That's the reason I give one cat example. So in my book, for example, we have an example of like giving a prompt, create an image of a cat doing Odissi dance. Okay. So ChatGPT, for example, generates this image. So, and the instruction that you give to a generative AI model are called prompts. So, what are AI agents? So, like now that AI is everywhere. So, as I told you, like for example, we have an intern. So, similarly, there are smart assistants are everywhere. So, for example, I have to write some like as a product manager, I have to do the market research. For example, I have an agent who kind of looks at all the different industry news that is going on and then feeds me every day, and that and then I take that to some it summarizes for me, and then I take it and then use it for my purpose, or for example use that research topic and write reports. For example, whenever there is a competitor product is being used, that how you are solving in our product. Okay, it can actually check for mistakes. For example, if I have written a doc, and I fed it to them, it can check for any mistakes, any kind of mistakes that I might have in quoting some industry number, or for example, our revenue number. It can go to the specific databases that we have and check for the mistakes. It can send this to you. It can close your like if you are a let's say software engineer, it can generate code for you. Okay, it can close tickets for you. So what agents what makes agents special? Because they can think vision, for example, and plan steps, whatever they think do. They can use tools, all the different kind of tools, email, Slack. They can use existing systems to calculate sales. They can learn from mistakes, and there are multiple, like for example, multiple uh, customer service people or multiple engineers can work together. Similarly, multiple agents can work together to make decisions. And the complex task can be divided into multiple small steps, for example, and agents can do the jobs independently. Why should you learn about AI? Future jobs. Now, for example, if you are a software engineer, you know, you can generate a lot of code. People are asking that question. Like, for example, if you are going to be a financial analyst, for example, like ChatGPT or Gemini or any other, LLM models can give you financial plan, for you. So, but if you don't know how to use this tool, you won't be able to be compete in the market space. It can solve big problems like climate research or health or education, um, and then you like, because if there is a lot of misinformation that is happening, there is a lot of bad things that is being it can help you to be safe, because there is a lot of bad actors that is trying to steal in your information, manipulate information to create wrongful videos or something. It will help you to be safe. And you know if you know AI, then you can tell others and be ethical. Like for example, sometime people are using it for wrongful usage. So you can tell them, try to be responsible and have fun. Like for example, you can create stories, create fun videos, create fun images uh, with AI, and it'll be like your superpowers. If you are a animator, it is going to give you a lot more power to you. If you are a dancer, for example, you can take your dance move, create reels whatsoever, So how do you get started with AI? You know, try different AI tools available. Play with Scratch or AI drawing apps or voice assistants. Learn coding, Python. It's great for AI. Take some phone courses, even if there are online courses available um, in YouTube, and ask an experiment, build projects. So this is what we learned today. I think there is another presentation. I don't want to take time from there. I'll take some questions, but before that, so that is, if you really, really want to learn more. So, there is this AI for Kids English book is available in Amazon, both in, worldwide, and also the Odia book is available worldwide. And if you are if you want to actually send some books to your school in Odisha or India, or even in the US or library, so you can go to aiforkids.info and then see how you can sponsor, copies of the book to your school. And you just go to the Google Doc, fill up the doc, and it can send in the information to the publisher, and publisher sends the books directly. And for every copy that you donate to a school in Odisha, we add another copy from our side. Thank you very much.
Debu bhai, there is one question for you from Joy Bhaina. Joy. Your examples are
Yeah,
in.
yeah. So these examples are actually from my book. So what I did, I gave the PDF version of the book to the model, and then told, try to use some of the images from my book too, while creating and basically, and make it, use the color and font for which is going to be appealing for the kids. So it was a very simple prompt. Uploaded the PDF of copy of my book, and then uh, that's it. So it actually took the examples of the cats, for example, from my book, all those, from my book.
Did you use Chat GPT or something else?
So it's our own model and AWS.
One model. Okay. I see.
Yeah, but I think probably Chat GPT, if you have premium version, it's going to do that for you too.
So is it your more generated by your company or something, or you?
Yeah. So basically, we basically use Claude, but we provide also, because as a product manager, for example, one of my job is to do a lot of presentation to customers. Okay.
Okay.
And I have to build a lot of presentation. Okay. So I think when the product is ready and we are building presentation, it's a lot more easier because you're putting screenshot or API or whatever you have. But when the product is not ready, and it's a little bit takes time to build the presentation. So what I've been doing now these days is that I use AI to generate the presentation. Just give our requirement, we give our requirement doc and generate the presentation. So I had never built a presentation for kids, but it did fairly good, just taking this
Looks
and
pretty
building it.
good.
Yeah.
Yeah. Thank you.
ଏଇଟା ଗୋଟେ ବଢ଼ିଆ ଡେ ଟୁ ଡେ କେସ୍ ପାଇଁ ଇଏଟା ବତେଇଲେ ବଢ଼ିଆ ହେଉଛି ଯେଉଁ ଥଟ୍ ପ୍ରୋସେସ୍ ଆମର ସବୁ ରହୁଛି ଆମେ ଡକ୍ୟୁମେଣ୍ଟରେ କି ଇମେଲରେ ଲେଖିକି ଦେଉଛେ ୱାଇ ନଟ୍ ପୁଟ୍ ଇଟ୍ ଇନ୍ ଏ ପ୍ରେଜେଣ୍ଟେସନ୍ ୱେ ସୋ ଇଟ୍ ୱିଲ୍ ବି ମୋର୍ ଆଟ୍ରାକ୍ଟିଭ୍ ରାଇଟ୍ ବଢ଼ିଆ ଆଇଡ଼ିଆ
Yeah.
ରାଇଟ୍ ଗ୍ରେଟ୍ ଆଇଡ଼ିଆ ସତ୍ୟ ୟୁ ହାଭ୍ ଏ କ୍ୱେଶ୍ଚନ୍
Vaina, thank you. Devu Vaina, namaskar. Thank you. More like my kids are watching actually. They want to tell something.
Thank you. We learned so much.
Yeah.
Thank you, Vaina.
Yeah, sure.
Bye.
Bye. Yeah, we can do a little bit longer session that we go a little bit more details about like how to train a model or so example code or something, but I think to begin with, you can go to AI for Kids, and there are also chapter wide videos available. if you can read the book with your, like, buy a book, and like my recommendation is that if you're young kids, buy the book and read the book to your kids. So because you always read a book, to your kids. So that's how basically you learn
Sure, why not?
quickly.
Thank you.
Yeah.
We'll do that. Yeah.
ଦେବୁ ବାବୁ ଆପଣଙ୍କର ସେ ଯେ ଓଡି ଫଣ୍ଡଟା ଆପଣ ଲେଖିଥିଲେ କି?
No, no, no. That is
ଆଉ
another
ଜଣେ different?
Debu. That is another Debu
ଆଚ୍ଛା
Patra
ଆଚ୍ଛା
from
ଓକେ
Sonpur. Mo hochi Debu Panda from Charsuguda.
ଆଚ୍ଛା ଆଚ୍ଛା ଓକେ ନାଇସ୍ ଓକେ
Yeah, but I have done a lot of technology work, not that, from the consumer driven side, mostly on the databases and all. I wrote 5 books on technology, six books, primarily on Java and databases and,
So what
analytics.
you gave this PDF file and created your slides, is the you think cloud can do the same thing?
Yeah, yeah, yeah.
Okay.
Yeah, yeah. Cloud can do ChatGPT. Anybody can do. I think. So I tried with ChatGPT. I had premium version, but recently I gave up because I was not using that much. But ChatGPT will probably do that because I ran out of tokens because I was using a free model, and Gemini couldn't do it, because they do not have a PowerPoint plugin, but
Okay.
in the free edition. So maybe in the premium edition, and they asked me to, like, for example, I wanted them to generate a Google Doc because the kids of this age, they do not use PowerPoint. So I wanted to create a Google Doc, but they want me to connect my Google account, and I didn't want to do that. My workspace, all kind of things. So,
Okay. Thank you.
but any model probably should be able to do this. Is like PDF generation and PowerPoint generation is generally one of the big use case, like productivity use case these days. And like we can discuss about some other aspect, like for example, these days, like I'll give an example of about a month and a half back, like we are building a new feature, like primarily on security aspects, AI agents and all. I cannot go details. Like for example, I was showing this to a customer about this is how the API will look like, this kind of thing, and the customer told, it will be very difficult to read this doc. Can you do a demo of, at least even if not implemented, it'll be good to read, see this parameter name and all. It's a demo rather than this. So we knew that engineering would take another 6 weeks to build a prototype before they can say our those to customer. So me and my product manager sat together and say, can we just use our, like, AWS's tool called Kiro to build a prototype of the API. It took about 8 hours to give. We fed our requirement doc with the API specification. It took about 8 hours, to give different customize the front, but it generated the whole API spec, okay, with test cases to test that API. So, the test cases were random, but in order to show to the customer that like the API definition, the parameters, how the errors will be generated, it was very good. So we didn't have to depend on. So like everybody's job is evolving these days. So, like for example, at least I see our product manager's job functions uh, are evolving quite a bit. Okay, with that, I think we should transition to Anjan.
Thank you, Dev. This was my most favorite part, AI for the kids. It always runs in my mind, like when we think of complex modeling, as was told by Professor Patra, like the idea of generalization was coming into the picture. And now, if the Feynman principle, right? First principle is like, if we can explain it to a kid, then you understand. If you don't, you cannot. So that's the reason AI for kids is one of my most favorite.
Yeah, think about, like, for example, when, how it came out, like when I was interviewing for a product manager within, like, I was in Oracle, I was interviewing for product management job within Oracle. Like the hiring manager asked, can you explain what database is to your grandma? So it was a struggle for me. How do I explain, database to my grandma? So I think it's, if you can explain to your grandma or the kids, then you can talk to your customers, very easily, I think.
I see two of my students, Sunil and Kajal. Kajal and Sunil. They are going to be in the AI Foundations batch, what we call it at Series 5. That's the fifth batch of AI Foundation happening across. So Sunil and Kajal, this is directly for you. Thank you, Devbhai. Anushka, like, how are we doing on agenda?
Yeah, we're doing pretty
Next
good.
is you.
We're a little bit short on time, though I know, so I think we should go ahead and fast track to the hands-on section.
So before, thank you, Anushka and Utkal bhai. Before I go into what my session, I would express my profound gratitude to Debu bhai. His ideas had set my ideas, and the AI for kids. Though we, so I allow me to express my gratitude to Debu bhai again. Professor Patra, on a very short notice, thank you for taking us through the computational modeling aspects of it and the problems of it. I'm taking your cue to um, towards the topic that was given to me. I am filling in for Amit today on ARC AGI 3. So I think I have about how much time I have? 6 minutes.
I think why don't you do this, Anjan? Just give a preview of it. I think the ARC needs a session by itself. So just provide a high-level preview and also the preview of the AI foundational course that you are leading. That will be very important information, so that because this requires definitely a lot of good focus to understand. This is a very good content you have made. I think it requires its own time to go through this. Give us a preview, and then let's try to wrap around like 15 minutes.
Right. Thank you. So, yeah, we'll do exactly the same. So the initial agenda was we will touch upon the foundations, which is transformer from one of the most important paper, that is attention is all you need. That was supposed to be the first item in the agenda, covering for 15 minutes. Then we'll be looking at AGI, that is artificial general intelligence, which everybody is talking about these days, and we're looking to some working with hands on this benchmark, which we have a team. And then we'll be looking into the AI fundamentals, a syllabus, right? So these were the outlines. So we will keep the outline as discussed, and instead of going into the details, I'll make this document public for those of you who are joining. I see engineering managers, PhDs in quantum information processing systems. I do see students in this forum, and I do see youngsters. Hello, everybody. I want you all to take a common sense approach of what is attention, right? Everybody say pay attention, right? So when we say pay attention, what today's exercise was into hands-on practice of attention ourselves. So the way that what I will do is I will demonstrate it. Those of you who follow along, that's great. If you do not follow along, that's okay. So what I'll do is, first round one, what we are doing is we are working on something called hands-on self-attention. I repeat, hands-on self-attention. In the common sense approach, when you say self-attention, we are attending to ourselves. We are paying attention to ourselves, right? Those of you who are spiritually inclined, Bhagavad Gita has something called Uddharet Atman Atmanam. Mathematically, that is inclined, but let's experience that. What do we do? Get yourself into relaxed standing. I am standing, so that's my relaxed position. And then keep your eyes closed. I paid attention to my breathing, inhaled and exhaled, right? Today, I would not do this 8 times, but whenever you can, think about it, right? Repeat 8 times. Why this 8? There is a secret to it. When you see a diagram, you will come in. It's 8 because when the transformer paper computationally implements it, there is something called multi-headed attention. And by multi-headed attention, I am taking you to a diagram directly. If you calculate this, where I'm moving my cursor, right? Is my cursor moving? Uh, are
Yes, it is
you're able
moving.
to see?
Yep, we can see it. We can see your follow your marker.
So why the number 8 is, this is the original transformers multi-head attention. If you see multi-head attention, so multi-head attention had something about 8, and hence whenever you are actually trying to experience transformers, when you want to fill in how does this large language models work, right? Think of one word, self-attention. If you are not taking note, please do take a mental note of it, self-attention, and it is easy to experience. I would have enlisted the help of a wellness expert, but that's okay. We will do it on a longer time. So that is self-attention. Then now on self-attention, think about doing the exact same thing. Paying attention, inhale, ask a question, then find the answer to the question, exhale. So that's about, we are paying an attention. While paying an attention, we are looking of three things. We are looking at a question, that's a query. We are looking at a question, that's a query. And when we ask a question, from the moment we ask a question, we go about finding the answers, certain keywords, based on certain keywords. And based on those keywords, we also find out our answer, which is called value. So now the transformers in self-attention mechanism work on these three things: query, a question, key, through which we get the answers, and value. Think about it like a dictionary. What is the meaning of the word culture? We are OSA, a cultural organization. What is the meaning of the word culture? Is the query. What is the key? culture. We go to dictionary, go to C, and then look into the key. And what is the value? Value is the dictionary definition, what is written in that culture. So the idea when we say self-attention, when we model self-attention, physical self-attention, which we are modeling it as inhale, exhale, and repeat of 8 times, is exactly transformed into a mechanism which I am taking you to the same picture that I showed into a, this is query, this is key, and this is the value. So query is what, first query, a single query would say, what is the meaning of culture? Keyword is culture, value is the dictionary definition. So the entire world is modeled to be working in this format. The so now when we say self, this is a very fast moment of self attention as we experience through inhale, thinking, and exhale into a computational model via queries, keys, and value. Mathematically, all of this happens mathematically via a single function. As Abani sir was telling a while back, I don't want to even look into the mathematics equation, but try to think of this as a attention function mathematically, which is softmax of query into key transpose by a scaling factor, square root of dk into v. These are all matrices. Those of you who are studying high school, I see some high school students here, you would actually have studied about linear algebra. And those of us in Odisha, we would remember Konark TV. This document will be shared. Now think of the TV. So think when you are thinking of vectors, think of a TV with all those lights with which, if there are actually tiny dots. Think of them. So now what happens is while we're modeling a large system, what we do is convert those large systems into a stream of query, key, and values in the form of vectors, which is computed. When we are actually doing self-attention, we are figuring out answers. So pictorially, when a self-attention happens, if you look at it, a sentence, it's paying attention of each other. So that is how the self-attention works pictorially. Now, this works in a sequencing models, right? Now, it is computationally very expensive. So optimization is needed. Because of optimization is needed, instead of 8 queries, key values, people try to optimize by reducing, by grouping. That's called grouped query attention, and details can be answered. I'm quickly jumping into generalization. You would have heard saying that in how a model will not work, in what scenarios a model will not work. That part, like it is working in dataset 1, will it work in dataset 2? Those kind of thinking is called generalization thinking. I want to call out one of our ODI community member, and the last speaker of OSA AI Club was Professor Barar. So Professor Barar's student, Swarup Misra, he created a paper called Self-Instruct, and using self-instruct along with the transformers with the zero set learning, I have referred each of these papers into this writing so that you can look into it. So today's large models have evolved out of transformers, which has key elements as self-attention combined with Sorup's self-instructions. Now comment. Almost all the models today are following this paradigm. Self-attention based transformer layered with self-instructions, right? Swarup Misra. He is a OSA member himself, and he lives in California. Right now he works with Microsoft, but he was a student of Professor Chitta Barar. They invented together this self-instruct paper. The link is linked. If you want to go into the details, you can go into that. I'm quickly jumping into the fact that intelligence has been a moving goalpost for the humanity. What I mean by that is when Big Blue, right, beat our gentleman called Gary Kasparov, like the chess champion, we thought, oh, we achieved intelligence. But then AI didn't work there. Those were special intelligence. When AlphaGo achieved, we realized that, oh, we reached some level of intelligence, right? And that paradigm comes. So intelligence is a moving goalpost. Scientifically, that needs to be governed. And hence, Mr. Soleil, like he's a French gentleman. I don't know. I mean, sorry, I didn't know how to pronounce his name, but he wrote this paper. He wrote this paper on the measure of intelligence, and based on which he created something called abstraction and reasoning corpus. Abstraction and reasoning corpus, based on which today's AGI is being calculated, right? So that is where the ARC AGI benchmarks are created. The ARC AGI benchmarks for visualization can be looked into this diagram, which I have pasted it here. So the on the measure of intelligence came about 2019, around 20 till this point in time, till this point in time, till 24, none of the models were able to actually achieve 20% accuracy on the ARC AGI1 benchmarks. However, 25 and 26, with the advent of reasoning models, jumped quite high, and ARC AGI 2 was achieved till 85% of the accuracy, 82% of the accuracy, right? Now, we are in a stage of ARC AGI 3, that's a benchmark. So this benchmark at this moment is calculating the human AI gap. Today, on all the games, Anushka, should we show what game we're talking about? So we have designed a system. When you say we, like ARC Prize has designed a system in which a human versus AI gap is being measured, where all the humans are performing at about 80% and the AI is working at 0% today. So, do we have time to show the game, or we will leave it? I think we are out of 8 minutes out, right?
Yeah.
So we will just
So
quickly.
let's talk about it. Yeah, I think we'll have to do this in a more focused way.
Yeah.
Yeah.
Okay. So what I would, yeah. So I'll quickly. So today so getting started. So this document is available. ARC Agency Quick Start. So I'm quickly taking you to a we will do a coding. We'll do a code session following on this later. Later in the sense in upcoming sessions. We do have a specific WhatsApp group that is focusing on ARC AGI. We need a lot of hands-on engineers, infra providers, etc., etc. In case of any questions, of course, OSA professional networking team would be uh, the best point of contact. Having said that, to build generalized models, we need fundamental thinking. Models, we need fundamental thinking. And hence, right now, we have an AI fundamental syllabus that is being brought in, and it is starting on 14th April in a different context. We would solicit your opinions on how, if you have to shape this syllabus in certain way, right? Some indicative questions are like, does it suffice? Does this syllabus suffice? And if you are designing a curriculum for kids in Odisha, what would you want to include? And you can actually extrapolate for if you are designing a curriculum for kids right here in the United States for the OSA community, what would you? And of course, those of you who are willing, you are welcome to the mentor pool via professional networking committee of OSA. With this, I am 10 minutes over the time, and I will take a pause if any questions. The link of the document, I'm going to paste it in the chat.
Anjan, in interest of time, why don't we make that announcement? I think there is a good program good curriculum that you have developed. Why don't you speak a little bit about it and then share the information how our audience can join?
Yeah, sure. So now we do have a program which is AI fundamentals. I'll go back to the same document. The last part. If we look at this section, thank you for the opportunity again. I would look into each of this, right? So what we are doing is the fundamentals that we are looking at here in the first session that is happening on 14th April in Odisha AI community. I think Kajal and Sunil, they are here. So they are lucky enough to be in the first group. So in the first day on 14th April, we are discussing the fundamentals. Why, what, all these W questions of AI. The second day, we are looking at intelligence, me and AI, right? Everyone looks at intelligence and artificial intelligence in their uh, own ways, right? It can start from how do I interact with an AI tool versus how do I create a digital clone. So, it would start with in building my first AI agent, of course, using the tools like LangChain and LangGraph. That is going to be the second. Third is, see, one objective that we are having at this is we want to make Odisha and these kids to actually making the next generation of intellectual next generation of intellect, so that we can make it as an intellectual capital of the globe, right? And we are very ambitious about it, and hence we are looking at theories of learning and optimization. So today AI, in case of large, it's applied optimization, as Professor Patra was showing in one blue box, saying that don't even look at it. So it's actually applied optimization, right? Then we were looking at theories of thinking, theories of imagination, reasoning, causality, hierarchy of abstraction, and then practical skills like learning to conduct literature survey and a survey of present AI landscape. Building wrappers, meaning simple application using AI-based coding tools to fit into certain use cases. That would need prompt engineering, context engineering, and as we heard today, harness engineering, right? End-to-end AI. So the idea is each of these kids coming to the class should be able to have a tiny applications of their own, which is doing end-to-end. And by end-to-end, we are not talking of large models. We are not talking of large models. We want them to achieve the same level of intelligence in their own computers, local computers, in the edge devices. That will generate a next level of Cambrian explosion of intelligence at the edge, and that would actually push us. So consciously, while there is big compute talk which is going on, individually I'm avoiding the big compute talk, though that would be a separate discussion when we are talking with enterprises, when we are talking with big tech. So end-to-end AI, by this, an objective is this kids should be able to use a little bit of reinforcement learning, a little bit of model of their own on their own.
10 minutes.
And we are soliciting support from great thinkers, engineering managers here. All of you can come and suggest the changes to the curriculum if you need. You can volunteer to be a part of the mentor pool. You can volunteer to teach a session. It is starting on 14th of April, and it would go till I believe August. Somehow aligned with Mahabisuva Sankrantiରେ ଆରମ୍ଭ ହେଉଛି, ସରିବ ପାଖାପାଖି ରଥ ପାଖାପାଖି ସରିବ। ରଥରୁ ଆଉ ଗୋଟେ ପୁଣି ସେସନ ଆରମ୍ଭ ହେବ, S6 ଆରମ୍ଭ ହେବ। S6 ପ୍ଲାନ୍ କରାଯାଉଛି କି we will merge traditional bit based thinking into quantum based thinking. So S6 ଟା quantum ରେ ଚିନ୍ତା କରାଯାଉଛି, S5 ଟା will be the last session focused on the bits on this. So OSA community is welcome to be a part of the mentor pool and teach these kids of this next generation. And these kids are eagerly waiting for industry leaders like Professor. They were super happy about listening from Debu Bhai and Professor Patra today. And like software-defined vehicle, Satya is in software-defined vehicle. I see, yeah, Angsuman is a business guy. There are a lot of thinking going on there. So you from industry are welcome to be a part of the mentor pool and teach. And in that way, those of us who are in North America, we are giving it back to Odisha, and probably it will generate a new blend of information, like new blend of information exchange, and elevate us, creating the next wave. Thank you.
Okay. With that, move to के screen share कर भी? Or am I co screen देखो चलो?
Session summary.
Now it's Session summary. Okay, all right. Tale just Anjan, thank you. That was a great conversation, great lead into. I mean, ARC AGI upre specific kote session kariya, jota ke it will be more focused like you gave. This was a quick preview. So just the session summary, just trying to understand. Ame kusuru arambha karthile, ame bujhiba arambha karthile. LLMs kono first duita episode re LLM guda hochante jente overall layman language re bujhiba gale. Large language models एमाने समझते बहुत वॉल्यूम्स पूरा इंटायर इंटरनेट ऊपर ट्रेन ही चंदी तेणु से माने incredibly smart autocomplete powered by whatever data they have seen. They have seen the patterns, they have seen the data, they know how humans interact, emails are written, how documents are written, everything they know, all the complexities. So that's what LLMs are. They are already trained. কিন্তু খালি ট্রেন ହେଇକି କହିଲେ କ'ଣ ହବ, we wanted some action. So that's what we saw in episode 2 and 3, ଯୋଉଥିରେ ଆମେ ଟିକେ agentic behavior କୁ ଗଲେ. Agentic behavior ରେ କ'ଣ ହଉଛି ନା model କୁ we provided some memory, some tools so it can go and actually do it. We saw Satya was giving a demo of how to book your flights, how to create great presentations आज भी ଦେଖିଲେ, and orchestrate କରିପାରିବେ long running tasks ଯୋଉଟା software engineer ମାନେ ଆଜିକାଲି यूज କରୁଛନ୍ତି. ଗୋଟେ orchestrator layer ରହିଲା, 4-5ଟା different task ରହିଲା, ସେଗୁଡ଼ା ଆମେ ସବୁ ଦେଖିଥିଲେ. ଆଗକୁ ବି ଦେଖିବା. ଆଜି ଅଞ୍ଜନ ଯାହା କହିଲେ ସେଟା ହଉଛି ARC AGI, ଯୋଉଟା କି now we are talking about କି data ଯୋଉଟା ଦେଖି ନାହିଁ, पूरा completely नूआ, ଗୋଟେ absolutely no idea କେମିତି କରିବ. Human have not provided the rule set, but can these LLMs, can these models, can these AI tools be good enough to crack those problems that they have not seen? So this is the next, and this is the future we'll be talking to. Okay. So thank you everyone for participating. मैं session 4 ପାଇଁ पुन थरे 2 weeks time रे देखावा. Thank you Anushka for running this. Thank you to all our great speakers, and thank you Anjan as always for coordinating. Satya is also the partner in this crime, so thank you Satya for always standing by. And Amit could not join today. He is also another coordinator who we spend a lot of time in building this content and getting into these sessions. Okay. Thank you, everyone. Have a great weekend.
Thank you, everyone.